So we are solving numericals for the second part of the chapter, which is motion in one dimension. This part relates to the graphical representation of motion in one dimension. So this is question number one. Let's look at the question. This figure shows the displacement time graph for the motion of a body. Use it to calculate the velocity of the body at t is equal to 1. So this is t is equal to 1. Well, let me change color so that whatever I write is visible on the paper. So this is t is equal to 1. This is t is equal to 1, and I need to calculate velocity using a displacement time graph. So at t is equal to 1, my displacement is here as per the graph, so which means displacement is 2. So I need to calculate the velocity. Velocity is equal to displacement upon time. So at t is equal to 1 second, velocity is equal to displacement, which is 2, upon 1 meter per second, which is 2 meter per second. And let's look at t is equal to 2 seconds. At t is equal to 2 seconds, which is this, let me see where my graph is. This, the value of displacement is 4. So velocity is equal to 4 upon 2 meter per second, which is 2 meter per second. And at t is equal to 3 second, which is t is equal to 3 second, this is where my displacement is, and this, when I read on the y-axis, is 6. So velocity is equal to displacement, which is 6 upon 3 meter per second, which is again 2 meter per second. Well, I didn't need to calculate any of this because from the graph itself I noticed that this is a straight line, which means it's a uniform velocity. Perfect. So I've calculated my velocity. The second part of the question says draw the velocity time graph. So at 0 second, what is my velocity? At 0 second, my velocity is 0 because the displacement is 0. So I will plot 0 time, 0 velocity. At 1 second, what is my velocity? 2. At 2 second, what is my velocity? 2. At 3 second, what is my velocity? 2. And at 4 second, my velocity is still 2. So if I need to draw the velocity time graph, this is my velocity time graph for 1, 2, 3, 4 second, and this is how it is going. So this is my velocity time graph for this question. Now we give me 1 second, I'll erase this question and come to the second question. So now we are on question 2. Question 2 says following table gives the displacement of car at different points of time. Draw the displacement time sketch and find the average velocity. So on the x-axis I have plotted time, on the y-axis I have plotted displacement. At 0 second my displacement is 0. So at this point I mark a point 0, 0. At 1 second my displacement is 5. So at this point I mark a point. At 2 seconds, my displacement is 10, so I mark a point to 10. Then is 3, 15, which is there. This is where I plot, and 4, 20. So I plot a point here, 4, 20. And then I join them with a straight line. Please note, I can't use a ruler, or at least I don't know how to use a ruler on this. So please use a scale that you have and join these points. When you join these points with a ruler, you will get a straight line starting from 0 and going up to there. Now let's look at the second part of the question. What will be the displacement of the car at 2.5 seconds? So where is 2.5 second? Well, 1, 2, 3, 4, 5, 6, 7, 8, which means 1, 2, 3, 4. This is 2.5 second. So let's draw a dotted line from here onto the graph. This is where I reach, and this is where I go onto the y-axis. Since I started from 2.5 second, I go here, I mark an arrow, and I reach here. How much is this? This is exactly 12.5 meter. 12.5 meter. Okay, done. What will be the displacement at 4.5 seconds? So my graph is beyond, I haven't drawn a graph which will go up to 4.5, but let's say if this was 1, 2, 3, 4, I didn't read the question properly. Otherwise, I would have drawn a bigger graph. You please draw a dotted line up to here and see where this line meets your graph. It'll meet somewhere here, somewhere outside. I can't see it, but that's where it'll be. Oh, I didn't read the first part. Find the average velocity. So velocity is equal to displacement upon time. So let's look at any specific point. So let's look at point at 2 second. Displacement was 10. So at 10 upon 2 second, which is 5 meter per second. That's my velocity. Now I can also calculate the distance displacement at 4.5 seconds. How? Because I know velocity is 5, displacement I need to calculate. The time is given as 4.5 seconds, which means therefore D would be equal to 5 meter per second into 4.5 second, which will be equal to 22.5 meter. Thank you. Let me see if I can add one more video to this. Let me try. So let's move on to question number 3. Question number 3 is given here. A body is moving. So I've already made the basic graph. I have plotted 0 minute, 0 second, 2 meter is the displacement, 1 second, 6, 2, 12, 3, 12, 4, 12, 5, 18, 6, 22, and 7, 24. I need to make a graph. So I will again use a ruler to join them directly. I am using a soft freehand. You should use a scale to join them properly. Let's answer the questions. Total distance traveled in the interval 1 to 5, which means from here till time here. This is what we're looking at. Well, we don't need to draw this on the graph. I'm just showing it to you for reference. What was the displacement here? 6. What's the displacement here? 18. Therefore, total displacement from 1 second to 5 second is equal to 18 meter minus 6 meter is equal to 12 meter. Well, let's look at the second part. Average velocity. Average velocity is equal to total displacement upon total time. Correct? So in this case, the total displacement as calculated above is 12 meter. And what is the time between 1 second to 5 second? Yes, 4 second, which is equal to 3 meter per second. Thank you.